One tiny engineering miscalculation, and a plane's journey would turn into disaster. The X-990 stood gleaming on the runway, a marvel of modern engineering. Passengers boarded oblivious to the hidden danger. Deep inside the aircraft's fuselage, a critical stress-bearing joint had been miscalculated. During design, its load tolerance, slightly underestimated. In the lab, engineers had overlooked this small error, buried in layers of complex calculations. Alone, it was almost invisible. But under flight conditions, the flaw could multiply stress across the airframe. As the engines roared to life and the plane accelerated, no one realized the silent countdown had begun. Back in the engineering lab, the flaw originated from a miscalculation in the wing fuselage joint. The material's stress tolerance had been slightly overestimated. Normally, the plane could handle turbulence, but at higher speeds and altitudes, the joint could fail. The engineers had assumed safety margins were sufficient. None imagined that a single calculation error, invisible on paper, would escalate into a structural nightmare in the sky. The stage was set. The flaw waited silently. Passengers settled in. Pilots ran final checks. The plane accelerated down the runway and lifted gracefully into the sky. The hidden wing fuselage joint flaw bore increasing stress with each passing second. At cruising altitude, the miscalculation remained dormant, a silent threat. To the passengers and crew, the flight seemed normal. But engineering physics had already set the countdown. At 30,000 feet, subtle vibrations began along the wings. Pilots noticed minor instrument fluctuations. The hidden flaw in the stress-bearing joint was spreading tension across the airframe. Microfractures silently formed, undetectable to the naked eye. Flight attendants walked the aisles, passengers oblivious. The invisible defect had begun to manifest physically in a quiet harbinger of disaster. The vibrations intensified. A faint metallic creak echoed through the cabin. Pilots attempted corrective maneuvers. The joint miscalculation caused uneven stress, bending parts of the wing slightly. Every turbulence amplified the structural strain. The flaw, once invisible, now influenced the plane's flight dynamics. The engineer's oversight was becoming a live threat in the sky. Suddenly, a loud metallic snap resounded in the cockpit. The stress-bearing joint failed partially, transferring dangerous loads to adjacent structures. Pilots fought to stabilize the aircraft, but the plane shuddered violently. Passengers screamed. The once smooth flight had transformed into a battle against an unseen engineering enemy. Physics, not human error, now controlled the plane's fate. Cabin lights flickered. Oxygen masks dropped. Turbulence intensified as the failing joint transferred stress to the fuselage. Pilots toggled emergency controls, yet every maneuver stressed the compromised structure further. The engineering flaw had become catastrophic, each second bringing the plane closer to disaster. The plane began an uncontrollable descent. Pilots attempted emergency procedures, but the failed joint prevented stabilization. Winds buffeted the plane as structural tension spread, fuselage creaking under pressure. Hope became fragile as the ground approached rapidly. The engineering error had turned a marvel of flight into a deadly trap. The plane crashed violently, wings breaking on impact. Smoke and debris filled the air. Emergency crews arrived quickly, assessing the wreckage. Investigators identified the cause: a single miscalculated stress-bearing joint. An engineering flaw invisible on blueprints but deadly in reality. Investigations revealed the overlooked design miscalculation. Aviation authorities issued new protocols for stress analysis and joint testing. The X-990 disaster became a stark reminder. No engineering flaw is too small. One miscalculation can change everything.